Welcome back, student. Now, today we'll discuss on the atomic packing factor. Today we'll discuss on atomic packing factor of HCb crystal structure. In the previous lecture video, already discussed on how to calculate the C by A ratio of HCb crystal structure. That C by A ratio is equal to 1.63 is already proved. Now we have to calculate the atomic packing factor of HCb crystal structure. We already some idea of HCb crystal structure, that what is the atomic arrangement in that particular metallic crystal structure. We already on that. Now the first point is that what is the effective number of atoms per unit cell now in case of hexagonal closed pack structure. So that is basically 6. Okay, and how do you know that that is 6 here? Because the atoms, total 6 corner atoms in the top plane or top portion and in a structure, and 6 corner atom in the bottom section. So total 12 corner atoms that share with is 1/6 position. So if you divide 1 by 6 plus 2 center atom which exist in the top and bottom plane of that structure, so that's why 2 that is share with the two sides, so that's why it is 1 by half, and 3 atoms which basically exist within the unit cell. So basically this is the within the unit cell, that's why this atom is basically not share anyone, so that's why 3 into 1. So that's after all calculation, so 6 into 12, that will be 2 plus 1 plus 3. So after all total number will be 6. So the effective number of atoms per unit cell is 6. Okay, or the total number of atoms that contribute of unit cell, that is 6. Okay, and as you know that the relationship between the lattice parameter or the distance between two atoms, that is A with R, that is basically R is equal to A by 2. Now therefore the volume of 6 atoms, as you know that the effective number of atoms, that is 6. So the volume of 6 atom with radius R will be, one atom volume is 4/3 pi r cube. Now 6 atoms volume will be 6 into 4/3 pi r cube, and you know that R is equal to A by 2. Now in terms of R is equal to A by 2, write down here. So that volume of 6 atom with radius R, that will be pi A cube, where A is the distance between two atoms. Okay, so now the volume of HCP unit cell. So as you know that atomic packing factor is equal to the volume of total volume of number of atoms. Okay, total volume of atoms divided by total unit cell volume. So total atoms volume, okay, that is basically pi a cube. Now volume of HCP unit cell, one unit cell volume of HCP structure, you can calculate is equal to area of base into height of the unit cell. How? Now area of base into height of unit cell. As you know that center, if you draw the line in with from the center atom to the corner atom, so they divide with 6 equilateral triangle. Now each is basically one is basically equilateral triangle, right? So each and individual is one equilateral triangle, right? Now so how do you calculate the one equilateral triangle area or volume? How do you calculate? That is basically area of base. So area of base into height of the unit cell. So area of base, suppose this is one equilateral triangle in which what you see here, CAB is one equilateral triangle from 1 out of 6. Now that area of base, that is basically area of base will be area of base will be AB, okay, and height of the unit cell, so this is the height, that is C. So the area will be area of base into height of the unit cell, so half into C into AB. So this is the area, this is the volume for one unit cell. Now when you calculate for the 6 equilateral triangle, so that will be 6 into half into, so into CE into AB, okay, 6 into half into CE into AB. So that will be the volume of one SCP unit cell. Now, what is the value of CE? So CE means the diagonal. Okay, so CE will be the value of CE. CE will be 6 into half. Okay, into C value will be root over 3 by 2 into into A into base of the unit cell, that is A. Okay, so the total volume of SCP unit cell will be 3 root over 3 under root 2 divided by 2 into A square. Okay, now that is basically the area of the base. Okay, so this is the area of the base. As you know, the total unit cell volume. So what is the area of the base? This is the area of the base. Now when you calculate the volume of SCP unit cell, so I am wrong. Actually, we have already. So this is the calculation for area of the base. So this is the area. So area of the base is area of the base is equal to 6 into area into triangle CAB. So one triangle area is half into C into AB. So similar triangle is 6. So that's why it's 6 into that one. Okay, that is the area of the base. Now you have to when you calculate the volume of SCP unit cell into height of the unit cell. That height is unit cell is basically here, that is C. Now this is your height of the unit cell, C. So into C. So this is the area of the base. As you know that the volume of SCP of unit cell is 3 root 3 A square divided by 2 into C. C is your height of the unit cell. We already discussed on the in the first lecture video of this SCP crystal structure. V will be 3 root 3 by 2 A square into C. As you know, the atomic packing factor is the ratio of total number of atoms volume, or volume of total number of atom divided by one unit cell volume. So that will be pi AQ divided by 3 root 3 2 A square C. Okay, so that will be, after that the equation will be 2 pi A, after calculation actually 2 pi A divided by 3 root 3 C. Now as you know that C by A ratio for SCP structure, that is 1.63. So the value is, so the value will be if you put these values here, C by here it is A by C. If you in terms of that, if you put this value 1.60, after calculation you can get the value of atomic packing factor for SCP structure is 0.74. Okay, now let us take an example on a numerical law. Calculate the volume. So this is a numerical. Calculate the volume of zinc crystal unit cell by using following data. Zinc has SCP crystal structure with the distance with, that is A, actually the distance between two atoms for SCP structure, that is given as 0.2665 nanometer, and 6 is and C is equal to 0.4997 nanometer. So the value of A and C are given, and you have to calculate the volume. So actually in the previous topic we already discussed that volume of one SCP unit cell is equal to 3 root 3 by 2 into A square into C. Okay, now use this equation. So V is equal to 3 root 3 by 2 into A square into C. So V will be 3 root 3 by 2 into A means 0.2665 the whole square into C. So after calculation you can get the value of volume of unit cell of zinc. So that is basically a SCP crystal structure. Okay, now let us take another example. So now find the atomic packing factor, packing efficiency. So packing efficiency and atomic packing factor both are same. The atomic packing factor basically defined or expressed with fraction in fraction, and efficiency in terms of percentage. Okay, that is the basic difference, but the main concept is same. Now in this problem, that you have to calculate the packing efficiency of germanium, that is basically Ge crystal. Now if the radius of Ge atom is 1.22 angstrom, if the radius of Ge atom is 1.22 angstrom, that means value of R is given, that is 1.22 angstrom. Now find its lattice parameter. And as you know, actually, that Ge or germanium basically it's basically follow the BCC crystal structure, and so basically the packing factor will be, as you note, that the packing factor for BCC structure is atomic packing factor for BCC structure is 0.68. So obviously the Ge atomic packing factor will be 0.68. Now the second part is that find its lattice parameter. Now, as it follows the BCC crystal structure, that means body center cubic structure, and for that the relations between A, means the distance between two atom or lattice parameter with the radius of the BCC structure, will be A is equal to 4R by root 3. So A is equal to 4R by root 3 is equal to 4 into 1.22 divided by, if you put this value in here, R is equal to 1.22, that lattice parameter will be coming out that 1.28 angstrom. Okay, so this is the lattice parameter for Ge crystal structure, which is basically followed a BCC structure. BCC basically body center cubic structure, in which the atoms are arranged in such way that it's basically cubic structure, means in 8 corner atoms are situated, and in between a unit, in between a center atom, it exists within this structure. That's why it is called body center cubic structure. Okay, thank you very much for your listening and watching me, and goodbye.